Greetings and salutations. In today's video, we're going to be focusing on quadratic sequences. Well, firstly, what are quadratic sequences and how do they differ from linear sequences? Well, from the last video, we know that linear sequences have the same first difference. Their first difference is constant, although with quadratic sequences, their second difference is constant. Now, you're probably asking, what is a second difference? Well, let me show you. In this question, they're asking us, find the nth term of this sequence and its next three terms. So this is the sequence, 3, 8, 15, 24, 35. So let's find the difference. So from 3 to 8, there is an increase of 5. From 8 to 15, there is an increase of 7. Okay, so already we can see that the first difference is not going to be constant. So it is 7. 15 to 24, that is an increase of 9. And 24 to 35, it is an increase of 11. So this is our first difference, right? 5, 7, 9, and 11. And in linear sequences, the difference is always constant. But with here, this isn't the case. So this is when the second difference comes in. So let's look at these differences. 5, 7, 9, and 11. Can you spot anything? This itself is a pattern. Because what's the difference between 5 and 7? Well, 2. 7 and 9, well, it's 2 again. And then 9 and 11, it's 2 again. And you can see that this is called the second difference. So with quadratics, the second difference is constant. And with this, we can see that it is constant. So this is a quadratic sequence. So in the first part of the question, let's just say, is to find the nth term of this sequence. So this is the first thing they're asking us to do. The second thing they're asking us to do is find its next three terms, but we cannot do that without finding the nth term, or, as I also mentioned in the last video, the magical formula. So what are we firstly going to do? Well, what is the formula of quadratic sequences? Well, it is an squared plus bn plus c is equal to 0. Now, firstly, a has a value, and a is half of the second difference. So in this example, the second difference is 2. So the value of a would be 1, because it is half of the second difference. N, as I mentioned in the last video, does not have any value. Well, it does have a value, but it depends on what you're trying to find. B and C is what we are trying to find when we're figuring out quadratic sequences, and it'll make more sense as I explain further. So, with quadratics, the first thing you need to do, well, is obviously write your formula, but find T1 and T2 by this formula. Then secondly, we're going to be using simultaneous equations. And then we have to find the value of B and C, and then we have to slot it into the formula to find our nth term, or our magical formula. So let's do so. We have to find T1 and T2. Let's find T1 first, okay? This is our formula. Let's put it into T1. Okay, so we know the value of A is 1, and N, the term that we are desiring to find is 1. So we know that the N's are going to change into the value of 1, because that is the term we are trying to find. So it's going to be 1 squared plus B, as I've mentioned, we do not know the value of B, so we're going to leave it alone. B, N again is 1 plus C equal to, now this equals 0, it becomes very important when we're figuring out T1 and T2, is because when we're finding T1, it is going to equal to the first term. So our first term here is 3. And this only applies when you're finding the first term, okay? Stay with me now. 1 squared is 1, and 1 multiplied by 1 is 1. So 1 plus B times 1 is just B, plus C is equal to 3. So then I'm going to move this 1 to the other side, and remember, when you're moving something across or over the equal sign, it is going to become its opposite sign. So B plus C is equal to 3 minus 1, so B plus C is equal to 2. Is this starting to look familiar? Okay, we'll find T2 now. So we're going to use the same thing. We know a, so an squared plus bn plus c is equal to 0. We know that a is 1, so we're going to put that in. And we know that n, since we're finding t2, the value is 2 squared, okay? Plus b, the n is now 2, plus c is equal to, now we're finding our second term. So what is the second term of the sequence? It is 8, so it's all going to be equal to 8. So 2 squared is 4, 4 multiplied by 1 is 4, plus 2b plus c is equal to 8. So then 2b plus c is equal to 8 minus 4, because when we're taking a number across or over the equal sign, it becomes its opposite sign. So now 2b plus c is equal to 4. Now would you look at that? b plus c equals 2, 2b plus c equals 4. Now if you've watched my previous videos, simultaneous equations is where it starts to come in. So now, second step is to do simultaneous equations. So b plus c is equal to 2, and then 2b plus c is equal to 4. This looks exactly like simultaneous equations. And when doing simultaneous equations, the first thing you need to do is to eliminate a variable, okay? So usually when it comes to quadratic sequences and you are at the step, people usually eliminate the c, because the c will always be by itself. Because, well, the c is always by itself. Quite sad, but, you know. So usually you just multiply by minus 1. It's the easiest thing you can really do. So then b multiplied by minus 1 is b minus b. C multiplied by minus 1 is minus c, is equal to 2 multiplied by minus 1 is minus 2. Okay? The c's, they cancel out. And then 2b minus b is b. 4 minus 2 is 2. So now we have the value of b. Okay? So, watch. We found the value of a. We found the value of b. Now we're going to find the value of c. And once we know all those values, we're going to put them all together to find our nth term. Because remember, with our nth term, the n is going to stay the same, because that is when we can find any term within this specific quadratic sequence. Okay? So now we're going to do the same. B plus c is equal to 2. Now we know that b is equal to 2. We're just going to write that down. So instead of the b, we're going to replace it with 2. So 2 plus c is equal to 2. And c is equal to 2 minus 2. So, c is equal to 0. So, yeah. Okay, now we're going to go back to our formula. So an squared plus bn plus c is equal to 0. Okay? Now, we know a is equal to 1, okay? N squared and n is going to be staying as the same, okay? Plus, well, b, what is b? B is 2. We found that value, so it's 2n. And then c is 0, so we're just going to leave it as so. But this part, equals 0, when we were finding t1 and t2, the equals part was quite important. But when it comes to your answer, you are not using equals 0. The only reason why that equals 0 is there is to find the t1 and the t2, okay? So when you're writing your answer, do not write equals 0, because, well, you can write equals 0, but that would mean nothing, because when you are trying to find, for example, t20, you write t20 down, equals this formula, and then equals 0 again, it's unnecessary. So don't write equals 0, just save yourself some time. So this could also just be written as n squared plus 2n, because 1, well, it's the same really. So n squared plus 2n, and this is our nth term. So this is the nth term of this quadratic sequence. Now if we read the question again, find the nth term of this sequence and its next 3 terms. This is the second thing we need to do. So we need to find its next 3 terms. Well, firstly, let's look at the sequence again. We have 1, 2, 3, 4, 5. We have 5 terms within this sequence, okay? And it's asking us to find this next 3 terms. So we have to find T6, T7, and T8. So T6. So we're going to write our nth term once again, n squared plus 2n. So wherever we have n, we're going to put in the term that we desire to find, which in this case is 6. So T6 is equal to 6 squared plus 2 bracket 6. So then 6 squared is 36 plus 12. So then T6 is equal to 48. So this is what T6 is equal to. Now we are going to find T7. So T7 is equal to n squared plus 2n. Do write the nth term each time just to remind yourself frequently. So T7 is equal to 7 squared plus 2 bracket 7. This is equal to 49 plus 14. So T7 is equal to 63. And then T8, so n squared plus 2n, T8, so we're going to replace the n's, 8 squared plus 2 bracket 8. So that is 8 squared is 64, and then plus 16, and then adding them together is 80. So this is what T6 is, this is what T7 is, and this is what T8 is. And that's it, and you've solved for it. You can write like the whole sequence out again. For example, if the question is written as 3, 8, 15, 24, 35, and then it has 3 blanks, you would write like T6. What's T6? 48, and then in the next blank 63, sorry, and then the next blank 80. What would you do if you are given this question? Find the nth term and verify, hence find T20. Hence just means or furthermore or just simply and. So if you're given 2, 7, 14, 24, and 34, firstly, let's find the difference, so which would tell us if it is linear or quadratic. So the difference between 2 and 7 is 5, so that's plus 5. 7 and 14 is plus 7. 14 to 23, that is plus 9, and then 23 to 34 is plus 11. So we can see already that the first difference has some sort of pattern. There, it is increasing by 2. So 5 to 7 is increasing by 2, 7 to 9 it is increasing by 2, and 9 to 11 is increasing by 2. So this is our second difference, which tells us that this is a quadratic sequence, okay? So if it's quadratic, our formula is an squared plus bn plus c is equal to 0. T1 is equal to, and difference, so a in this case is equal to 1. So 1 n squared, so the term that we are desiring to find is 1, so that is what n equals to, 1 squared plus b, and then squared 1 plus c is equal to, and then for our first term, it is going to be equal to 2 because that is what the first term is. So then 1 squared is 1, and 1 multiplied by 1 is 1. So plus b plus c is equal to 2, and then b plus c is equal to 2 minus 1. B plus c is equal to 1. So this is our first simultaneous equation. So now we have to find T2. We know that a is equal to 1, and n is equal to the term that we desire to find, which in this case is 2 squared plus b squared 2 plus c is equal to our second term in this sequence is 7. So it is all equal to 7. So 2 squared is 4. 4 multiplied by 1 is 4. B multiplied by 2 is plus 2b, and plus c is equal to 7. 2b plus c is equal to 7 minus 4. So 2b plus c is equal to 3. So this is our second. Now that we have our two equations, b plus c is equal to 1 and 2b plus c is equal to 3, now we can find the value of b and c. So then again, we're going to just multiply by minus 1. It's probably the easiest thing that you can do. So b multiplied by minus 1 is minus b. C multiplied by minus 1 is minus c. And then 1 multiplied by minus 1 is just minus 1. And then the c's cancels out. 2b minus b is just b is equal to 3 minus 1, so that is just 2. So we know that b is equal to 2. So now we can find what c is equal to. So b plus c is equal to 1. We know that b is equal to 2. So 2 plus c is equal to 1. So c is equal to 1 minus 2. So c is equal to minus 1. So this is what c is equal to. Now we're going to just put in all the values that we know into our formula. So our formula is an squared plus bn plus c is equal to 0. So a is equal to 1. n squared, we're just going to leave it as. B has the value of 2n, and then c is minus 1. As I mentioned in the last question, we are not going to include equals 0. So, well, this can be written as 2n squared plus 2n minus 1, and this is our nth term. Although in the question it asks us to find t20. But beforehand, we have to verify. Now, there are a few ways you can verify this. You can go and look at the sequence again. So I'll rewrite the sequence. So the sequence is 2, 7, 14, 23, and 34. Okay, this is our sequence. By verifying, which I did in the last video, is you can take this nth term and you can find the term that is already shown before. So we have 1, 2, 3, 4, 5. We have 5 terms within the sequence. So we could find term 3. And if we use this to find term 3, it would be right. We know it would be right because, well, term 3 is right before our eyes. So if we do get this, we know that we can trust our nth term and we know it is right. So let's find T3, okay? And you can find anyone. You don't have to specifically find T3. You can find T1, T2, T4, or T5. So T3 is equal to n squared plus 2n minus 1. So T3, so it's 3 squared plus 2 bracket 3 minus 1. So 3 squared is 9 plus 6 minus 1. And there we go. That is all equal to 14. So we know that we verified right. And we know that our nth term is right as well. So now we have to have the job of finding T20. So we're going to rewrite our nth term once again, n squared plus 2n minus 1. So we're going to slot in 20 where we have n, so T20 is equal to 20 squared plus 2 bracket 20 minus 1. So 20 squared is 400 plus 40 minus 1, and this is all equal to 439, and this is our answer. So that is that. Thank you for watching.